Welcome to homework.
Okay, we have got to synthesize this molecule from 2-chloropropane and 1-butene as our only sources of carbon. So we can follow some retrosynthetic steps to determine what the forward synthesis would be. Now, when I look at this molecule on the left, the first thing I see is potentially breaking that bond, because this looks like this skeleton there, and this looks like this carbon skeleton here. Okay, so how could I get this from the component parts that I've broken apart? To me, this looks an awful lot like the product of a Grignard reaction. So let's continue on with our retrosynthesis and see what Grignard reaction I'm talking about. So if we had a Grignard reagent, magnesium chloride, and an aldehyde like this, and we reacted them, their product would be, after an acidic workup, would return us to up here, essentially. So this is going to be the Grignard step that we're told we have to use. We still have to continue on with this retrosynthesis and determine how we get from here to here and how we get from here to here, but we've got a pretty good start. Okay, let's start with the aldehyde. How would we make that aldehyde? Or what can we infer if we follow this aldehyde backwards? Well, we know that we can oxidize an alcohol, like a primary alcohol, into an aldehyde using maybe PCC. So that implies that we may have started from an alcohol. And then how would we get a primary alcohol from an alkene? Probably sodium borohydride and peroxide could give us the primary alcohol from this alkene. So we know it can be done. We know we can make a primary alcohol from this alkene. Okay, what does the magnesium chloride imply we had before it? That's not too bad, because we know if we start with our 2-chloropropane, if we reacted that with magnesium and ether, we would get a Grignard reagent. So now we should be able to do this all in the forward direction. That is, we put these parts back together, but instead of, like, we actually give the reaction conditions that would give each of the previous products. Okay. So how do we get a primary alcohol from an alkene? So hydroboration, oxidation is what we're looking for here. So the steps for hydroboration, oxidation, are BH3 in THF. THF is the solvent, followed with, in a second step, hydrogen peroxide and sodium hydroxide. Okay, that will turn this alkene into a primary alcohol. How do we oxidize a primary alcohol into an aldehyde? I recall that we don't want to use just any old oxidizing agent, otherwise we would get a carboxylic acid. PCC is one such oxidizing agent that will stop at the aldehyde and not go all the way to the carboxylic acid. Like, say, potassium permanganate would give us a carboxylic acid, but PCC will. How do we make the Grignard reagent from just the 2-chloropropane? We need magnesium, and we need to do this in diethyl ether. how do we bring them together? Well, we simply add them together. So we'll just put a plus here. And then technically, the product of this Grignard reaction, if we combine the Grignard reagent and the aldehyde, would look something like this. O minus with Mg plus next to it. So if we wanted it to be an alcohol, all we'd have to do is do an acidic workup. So we could say HCl and H2O to give us our final product. There we are. That's a complete synthesis of the shown molecule from 2-chloropropane and butene using a Grignard reaction.